Hi guys, welcome back. So today we're solving some complex problems on partial derivatives. Okay, so here we have an example where we have to find the partial derivative of it, and as you can see, this function is in two variables. So first we will find the partial derivative of this function with respect to x and then with respect to y. So this notation simply means partial derivative of z with respect to x and partial derivative of the function z with respect to y. And this can also be written as f of x. This simply means the function, the partial derivative of the function f means function, okay? F with respect to x or f with respect to y simply. So these two notations means the same thing. Okay, now taking the derivative of this, so here did you notice that this is a chain rule because here there's a function inside it as well. So first you will take the derivative of it like you would normally do. For example, if you had like x to the power of 4, so how you would take the derivative of this, so you will simply do 4x to the power of 3, right? Bring 4 down and subtract 1 from it. So we'll do the same thing first here and here. So we will bring the 1 down. Okay, so wait. So bringing the 1 down here, so we will write negative 1 x to the power of 3 negative y squared, and then we'll subtract 1 from it. So negative 1, that's negative 2. And now this is the chain rule. So in the chain rule, we have to multiply by the inside function, right? So we will multiply by the derivative of the inside function. So to calculate the derivative of this, we first need to consider that we are taking the derivative with respect to x, which means we are treating y as a constant, okay? So we are differentiating with respect to one variable, so we treat the other variables at variables constant, okay? So taking the derivative of this, so here we're treating y as a constant, so we know this is going to be 0, and we're only differentiating x, so 3x squared, and that is just 0, so you're not gonna write it. Okay, so let me explain once again. So what I did, I took the derivative of this just like that, x to the power of 4, so 4x cubed, right? So I took the derivative of this, bring 1 down, and this remains same, right? And then subtract 1 from it. And then since it's a chain rule, it's a function to the power of something. So this is a chain rule, right? So for that, I'm gonna have to multiply this function by the derivative of the inside function. So the inside function is this, x cubed minus y squared. So I'm gonna have to multiply by the derivative of this inside function. And to take the derivative of this function, I just have to consider the fact that I'm taking the derivative with respect to x and treating y as a constant, okay? So this x cubed, it's like taking the simple derivatives like 3x squared, and this negative y squared is going to be 0 since we're treating y as a constant, okay? So if you simplify this a little bit, so it's negative 3x squared times x cubed minus y squared and negative 2. So this is the answer for the f of x. Okay, now let's move on and find f of y. So first we will do the same thing, take the derivative of this just like this, okay? So bring 1 down and write this function as it is, and then subtract 1 from it, so it becomes negative 2. And now you have to multiply by this inside function, but we have to multiply by the derivative of this inside function, okay? So this inside function is x cubed minus y squared, and now we're taking the derivative with respect to y, so we are treating x as a constant, okay? So we are differentiating with respect to y, so treating x as a constant, so this is 0, and then this negative 2y. So bring 2 down and subtract 1 from it, okay? So now let me just write it neatly. So this becomes, so this negative negative cancels out, becomes 2y times x 3 minus 2y. Okay, so this is the answer for f of y. Now let's move on. Alright guys, this is our second example. So here, this example is x e to the power of x cubed and y. So here you can see that this is a function and this is another function and they are multiplying. So if two functions are multiplying, what is this? Yes, you're right, it's a product rule. So do you remember the formula of the product rule? If you don't, so let me recall, it's f prime times g plus g prime times f. So this is the formula of the product rule, where f is the first function and g is the second function. So in our case, f is the first function, x, and g is the second function, e to the x cubed y. Okay, now, so this is z equals 2. So we will find the derivative of z with respect to x. I'm sorry, the partial derivative. Okay, so the partial derivative of z with respect to y, or we can write it as f of y or f of z. It's the same thing. Now, when we are finding with respect to x, we know we're treating y as a constant. Okay, so we're treating y as a constant. So remember this, and now we will take the derivative of this function. So we are treating y as a constant and only differentiating x. So what's the derivative of x? It's 1. Now g prime. So here you see this is a chain rule. So just recall what's the derivative of e to the x. It's simply e to the x, right? So we will just write this as it is. But then it's a chain rule, so you'll have to multiply by the derivative of this inside function. So this inside function is this that you see at the top. So you will have to multiply by this the derivative of this inside function. So this inside function is x cubed y, and what's the derivative of this? We are treating y as a constant, so it will just stay there, and you will take the derivative of this x to the cube. So it's going to be 3x squared. So now we will write it over here, 3yx squared. So the derivative of this is 3y squared y, because we're treating y as a constant, so it will simply stay there, and taking the derivative of 3x squared. Okay, so now when we have our f prime, g prime, everything, so now let's just plug it into the formula. So first we write f prime. So what are we doing? We are using this formula to write our partial derivative with respect to x. So what is first? So first is f prime, so f prime, then g, so g times g, and then plus, it's a y, okay, it looks like a g. Okay, and then plus g prime, so this is g prime, so this is 3y x squared e to the x squared x cubed and y, and then times f is this. Okay, so now write everything neatly. So let me have some space. Okay, so writing everything together is x e to the x cubed y plus, okay, so this x and x multiplies, so 3y x cubed, because multiplying adds the exponent. So this is 1, this is 2, so it's 3, and then e to the xy. Okay, now you see that these are the same thing, right? So you can factor them out if you want. And sorry, this has to be at the top. So you can factor this if you want, but if you want, this is the answer. So now go ahead and factor this. So if you factor this, so this is 1 plus 3y x cubed, right? So this is the answer to the derivative with respect to x. Okay, now moving on to the derivative with respect to y. So how do we find the derivative with respect to y. So remember, we are treating x as a constant, okay? Always remember to write this so you don't confuse yourself. Okay, so we were doing the same thing, our f and g, but this time our f prime is g prime doesn't remain the same because we are treating x as a constant, not y as a constant like we did previously. So we'll have to write our f prime g prime again. Okay, so now f prime and g prime. So f is our first function, g is our second function. Now f prime, we're treating x as a constant, and what's the derivative of x? It's simply 0 because it's a constant. Now taking the derivative of g prime, so e to the x, it's simply e to the x, and then times the inside function, the chain rule. So this inside function is x cubed and y, and this x is a constant, so what's the derivative of y? So the derivative of y is 1, and the derivative of y is 1, so we don't write it, right? And x cubed is a constant, so it just remains there. So this is simply x cubed, okay? So I hope you got it. So the derivative of this inside function is x cubed y because x is a constant, so it will just stay in there, and we're differentiating y, so the derivative of y is simply 1, so that's why it's this. So now it's simply plugging into the formula. So f prime is 0, f prime times g, the whole thing is going to give 0, so you don't have to write it, because if you don't get it, then I can simply write it. So f prime times g, and then plus g prime, so g prime times f, which is this. So now you see it's 0 times something, so it's simply 0, so you don't have to write it. Okay, so here x times x, this is x to the power of 4, and e to the x to the power of 3, and y. So this is the answer to f of y. Okay, now let's move on. Alright guys, this is our third problem. So here we have z equals to ln of x for u squared plus 5v cubed. So we'll have to find the derivative of this function. So here, you guys notice that this is not x and y, this is u and v. So right, we have to find the derivative of this with respect to what? With respect to u, correct? And then with respect to v, right? Because this function is in the form of u and v. Okay, or you can simply write f of u or f of v, it's the same thing. Okay, so now let's find f of u. So when you're finding f of u, remember you're treating v as a constant, right? So when you're differentiating with respect to one variable, you treat the other as a constant. Okay, so remember how you take the derivative of ln of 2x. So in Cal 1, so you would do like, so there's a formula to do this. So you have to do like u prime times u. So to find the derivative of ln of something, you always have to do u prime over u. Okay, so, and this u is this inside function inside the u, inside the ln. Okay, so in here we have 2x, so u is our 2x, so you write at the bottom 2x, and what's the derivative of 2x? It's simply 2. So now you cancel these 2, and then you're left with 1 over x. So I hope you get it. So let's do another problem. So what's the derivative of ln of 3x? So you have to do u prime over u. So u is this inside function, so you write it at the bottom, 3x, and what's the derivative of 3x? It's simply 3. So you cancel these 3's out, and then 1 over x. Okay, so I hope you recalled how to find the derivative of ln of x. Now let's use this to find the partial derivative of ln of this function. Okay, and with respect to u first. Okay, so now we know we're doing u over u prime. So let's write u at the bottom first, which is this thing. So 4u squared plus 5b squared, we wrote over u. Now we have to take the derivative of the u. And remember, v is the constant, okay? So this 4v squared, 4u squared, it's bring the 2 down. So 4 times 2, that's 8u, and 2 minus 1, that's 1, okay? Plus 5v cubed. But we're treating v as a constant, so this whole thing goes to 0. So the derivative of this is simply 8u over 4u squared plus 5v cubed. And that's it. Now, moving on to f of v, we are treating u as a constant, okay? So write u at the bottom. So u is always the same. So u is the inside function, okay? This is the formula to find the derivative of the ln of something. It doesn't have to do with something with these variables u and v. It's simply a formula, okay? So u is the thing that is inside the ln. So here you write it at the bottom. 4u squared plus 5 of v cubed. Now the derivative of this function at the top. So we're treating, remember, u as a constant, so u is here. So this whole thing becomes 0 because the derivative of constant is 0. And then here the derivative of this one, 5 times 3, which is 15 v squared. So the derivative of this is simply this. Okay, now let's move on to another problem. Okay guys, so this is our last problem. So here we have z equals to cosine squared of 5x plus sine squared of 5y. So we have to find the derivative of this with respect to x and y, since this function is a 2-variable function. So with respect to x and with respect to y. Okay, so for this, first you have to notice that this function is a chain rule. If you cannot see that this is a chain rule, then you can write it like this as well, so that it's easier for you to find out that it's a chain rule. Okay, so if you write it like this, since it's a cosine squared, so you can write it like this at the top squared. If you write it like this or this, it's the same thing. So if you're having difficulty to find that if it's a chain rule or not, first step is to write it like this. So now you can see that this is a chain rule, since it's a function to the squared, and a function to the square is a chain rule, okay? So now let's calculate the derivative of this, the partial derivative of this with respect to y. Again, we're treating y as a constant. Okay, so first take the derivative of this. So we take the derivative of this one. So 2 cosine 5x, and then 2 minus 1, that's 1. And now we have to multiply by the partial derivative of the inside function, okay? In Cal 1, you would multiply by the inside function, the derivative of the inside function, but here you have to multiply by the partial derivative of the inside function, okay? Because it's a chain rule. Okay, and here we have cosine 5x as the inner function, and to take the partial derivative of this, let me recall that if you were to take the derivative of this one, like suppose you're in Cal 1 class and I'm asking you to take the derivative of sine of 2x, so how you would do that? So first you will just take the derivative of this, like sine of 2x. What's the derivative of this? So it's cosine 2x, right? Simply the derivative of sine x, it's cosine x. And now you see this is a chain rule as well, because the 2 is the inside function, the 2x is the inside function, so you have to multiply by the derivative of the 2x. So what's the derivative of 2x? It's 2, right? So you will just multiply by 2. Okay, so let's do this again. So the derivative of sine of 2x is what? It's cosine 2x, and then times the derivative of the inside function. So the derivative of 2x is 2. Okay, let's do another problem just to make sure it's clear. Okay, now cosine x. So cosine x, what's the derivative of cosine x? It's negative sine x, right? So negative sine 2x. And now we have 2x here. So what's the derivative of 2x? It's 2, right? So you write a 2 in front. Okay, now I hope it was a good refresher. Now coming back to this. So here we have cosine of 5x, okay? So you have to remember that this is not the derivative like Cal 1. This is Cal 3, okay? So you're treating y as a constant. So if there were y, so you would treat it as a constant. But here, there's no y, so you can simply take, so you're only differentiating x here. So what's the derivative of cosine of 5x? So the derivative of cosine x, it's negative sine 5x. And then multiplying with the derivative of the inside function, which is 5x. And what's the derivative of 5x? It's simply 5. Okay? So this is it. Now, let me write it neatly at the bottom. So here, if you simplify this, 2 times negative 5, that's negative 10. And then cosine 5x and sine 5x. Okay? But we're not done. Don't forget this. Okay? Now, we are going to differentiate this. Okay, so then the 2 goes down. Okay, and then this stays the same. And then what's 2 minus 1? That's 1. And now times the derivative of this inside function. Okay, and the times the partial derivative of the inside function, right? And this is sine of 5y. So here, do not write like the derivative of sine y is cosine y, so you would write like 5 sine, 5 cosine of 5y. No, this is wrong, because remember, we're treating y as a constant, so you cannot do that. So this whole thing becomes a constant. So, and what's the derivative of a constant? Right? It's 0, right? So if this thing multiplies by 0, so this whole thing goes to 0. So this is the answer then for the derivative with respect to x. Now, moving back to the derivative with respect to y. And by the way, guys, I'm shooting this video for the 4th time because there was many components to explain. So I was keep making mistakes. So make sure you subscribe or like this video and leave a comment in the description below that if you find my explanation useful or not, because I'm working really hard. Okay, now coming back to the problem. So here we are treating the we're taking the derivative with respect to y. So now we are treating x as a constant. Okay, we are finding the derivative with respect to y, so we're treating x as a constant, okay? So this is the problem that we're dealing with. So first, taking the derivative of this one, so 2 cosine 5x, right? Bringing the 2 down, and 2 minus 1, that's 1. And then, and by the way, if you write the 1 or not, it doesn't matter. I'm just writing it so you don't confuse, but it doesn't matter if you write it or not, okay? Okay, and now you have to multiply by the inside function, right? The partial derivative of the inside function. And what is this inside function? It's cosine of 5x, okay? I wrote it really badly. Let me write it once again. Okay, cosine of 5x. And what's the derivative of cosine of 5x? So the derivative of cosine x, it's negative sine 5x. And what's the derivative of 5x? It's 5, right? So this is it. And now, tell me, is this correct? No, it's not correct. Why? Because, remember, we are treating x as a constant. So yeah, you do not do that. We are treating x as a constant. That means this whole thing is a constant. And what's the derivative of a constant? It's 0, right? So this whole thing is 0 then. Okay. Now, what do we have next? So we have this function in here, sine of 5y squared. Now taking the derivative of this one, sine 5y, bringing the 2 down, subtracting 1 from the 2, and then times by the inside function. And now we're treating x as a constant. There is no x here, so you can simply differentiate the y. So sine of 5y, the derivative of sine y is cosine y, cosine 5y, and then times the derivative of 5y. And what's the derivative of 5y? It's simply 5. Now writing it all together, so 5 times 2, that's 10, sine 5y, cosine 5y. And this is the answer. Okay, I hope you guys find this video helpful. Let me know in the comments if you have any question, and thanks for watching. Bye.